Machine learning sounds complicated, but it's actually one of the simplest ideas in modern technology. Every time you hear words like artificial intelligence, ChatGPT, or self-driving cars, machine learning is working behind the scenes. In the next few minutes, I'll explain machine learning from zero, the three main types of learning, the models used in each, and finally, what models power generative AI. No math, no coding, just concepts, made simple. Machine learning is when a computer learns from data, instead of being manually programmed for every rule. Normally, a programmer writes instructions like, if this happens, do that. But in machine learning, we do something different. We give the computer examples, and the computer figures out the rules by itself. For example, instead of telling a computer how to recognize spam emails line by line, we show it thousands of emails labeled spam and not spam. Over time, the machine learns patterns. So the simple idea is this: data goes into patterns are learned to predictions come out. That's machine learning. There are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, you have labeled data, you predict known outcomes. Models like regression trees and neural networks are part of the supervised learning. In unsupervised learning, there are no labels. You discover patterns and structure. Models like clustering, PCA, and autoencoders comes under unsupervised learning. In reinforcement learning, there is no fixed data. Learning takes place through rewards and actions. Models like Q-learning and DQN are part of reinforcement learning. Generative models such as ChatGPT, Gemini, Grok, etc. are created using this technique. That's the full machine learning landscape. Now let's go through them one at a time. The first and most common type is supervised learning. Supervised learning means you train the machine using data that already has answers. Think of it like a teacher in a classroom. The teacher gives you questions and solutions. You learn by comparing your answers with the correct ones. Let's take a simple example. Imagine predicting house prices. You have data like house size, location, number of bedrooms, and you also know the final price. The model learns the relationship between these inputs and the output. Another example is email spam detection. Emails are already labeled as spam or not spam. Supervised learning usually solves two kinds of problems: classification, predicting a category like spam, or regression, predicting a number like price, temperature, or sales. Common supervised learning models include linear regression, logistic regression, decision trees, random forests, support vector machines, and neural networks. The second type is unsupervised learning. Here's the big difference. There are no answers given. You only give the machine raw data and ask it to find structure on its own. For example, imagine a company with millions of customers. Nobody labeled them as budget customers or premium customers. Unsupervised learning can analyze behavior and automatically group similar customers together. This is called clustering. Another use case is anomaly detection. If most data looks normal and something looks very different, the model flags it as unusual. This is often used in fraud detection and cybersecurity. Common unsupervised models include k-means clustering, DBSCAN, hierarchical clustering, PCA, for reducing dimensions, and autoencoders. Unsupervised learning is all about discovering hidden patterns. The third type is reinforcement learning. This one works very differently. Reinforcement learning is learning through trial and error. Think of training a dog. Good behavior gets a reward. Bad behavior does not. In reinforcement learning, an agent interacts with an environment. The agent takes an action, gets a reward or penalty, and slowly learns what actions are best. This approach is heavily used in games and robotics. For example, when an AI learns to play chess, it doesn't know the rules at first. It tries, moves, loses, wins, and slowly improves. Common reinforcement learning methods include Q-learning, deep Q networks, or DQN, policy gradient methods, and actor-critic models. Generative AI is a special category of machine learning. Instead of just predicting an answer, generative AI creates new content. It can generate text, images, music, code, and video. Most generative AI systems are built using deep learning, especially the following model families. First, one of them is transformers. Transformers are the foundation of modern text AI. They learn how words relate to each other and predict the next word in a sequence. This simple idea, scaled massively, creates powerful language models. Second one of them is called diffusion models. These are widely used for image generation. They start with random noise and slowly transform it into a clear image. Third categories of models is GANs, or generative adversarial networks. Here, two models compete. One generates data, the other judges it. And finally, the fourth model is VAES, or variational autoencoders. They learn a compressed representation of data and generate new samples from it. So when people talk about generative AI, they're usually talking about transformers for text, diffusion for images, and GANs or VAEs as classic generative models. And that's machine learning, explained from scratch. Supervised, unsupervised, reinforcement, and the models that power generative AI. If this helped you understand machine learning clearly, like the video, subscribe to the channel and comment what topic you want next. This was Machine Learning, the ultimate guide for dummies. If you liked this explanation, I also have short, focused videos for individual machine learning models. Each video helps you get started fast, what the model is used for, why you should choose it, and how it actually works in practice. I also walk you through training the model step by step and deploying it in real environments using Python and Google Colab notebooks that you can try instantly. No setup required. In just 50 minutes, you can run your first model, see predictions, and understand what's happening behind the scenes. And if you want to go deeper, I also have videos that explain what happens inside the model, how predictions are made, and how training and testing really work, model by model. So check out the videos on screen right now. Pick a model and start building today.